Good evening, everyone. Today's session is on cache memory. So, cache memory is basically is a very fast, efficient, and when we have when we have in a architecture or you have in a computer architecture, when you want to execute the pages, we have to switch on the number of pages. We want to replace the number of pages like Google results so fast. How it happens? Like as soon as you type and give the command to that particular thing, it is going to have a number of things. How fast? How basically how it works, right? So we will be studying today this concept of cache memory. We will understand where it is becoming, how it is becoming an architecture, how it is taking place, an important taking place in an memory architecture, right? How it basically replaces the pages from main memory to cache memory. Different page replacement algorithms are being used for replacing the pages. How it basically replaces the pages, and it so frequently, which type of algorithm it is going to use, right? So we will be have a brief introduction to this particular topic. So let us see what is a memory. Memory is like our brain, right? It stores something. So it's like that only. A memory is just like our human brain. It is used to store data and instructions. Like we store some memories, we store some feelings. We we don't have feelings in our brain, but sometimes we have to follow. So whatever we store in our brain, like hardware also, we have to store some data, some instructions. Computer memory is the storage space in the computer. So like we have our brain. In system it is also the memory, right? So we have different types of memory for holding different types. You may have temporary data, or you may have some permanent data. According to the memory type of memory, we will be saving the instructions and data. So where data is to be processed, right? Where data is stored, where it is processed, where it is sent to the computer for performing the particular action. Like our brain, our neurons are sending the messages to the human brain, and then it reverts, and then how we react, right? It is same as with our memory also in our computer. The memory is basically divided into large number of small parts called cells. Like we have neurons, it has cells. Neurons gets activated, but in our like memory we have small parts called cells. Each location where your or cell has a unique address. You can store your data, you can send your data, you can process some data according to that. So basically our computer memory is divided into two types of memory: primary and secondary, right? So primary is again divided into RAM and ROM. So RAM basically is static RAM or dynamic RAM, sorry. And ROM is, we have again number of types of ROM as well: PROM, EPROM, double EPROM. So according to the like usage, we use different types of memory. In secondary memory, like we have in today's life, we are using hard disk, SDDs, we are using pen drives, we are using. Earlier we were using CDs. Now, like in our laptops, there is no provision of CDs. Why? Because we switch to uh, advanced hardwares. It is working on different things, right? But every you may have to understand this thing. Every hardware has its own advantage. Whether it is SDD, whether it is SSD, whether it is compact disk, whether it is floppy disk, whether it is pen drive, or earlier we have magnetic tapes or punch cards, whatever we have to store the data. Right. Next thing is our memory is primarily divided into three types. What are those? Main memory, secondary memory, and cache memory. So here I have not given the example of cache memory because we will be checking it out how cache memory works. So here it comes like cache memory is in the structure only. But let us see how it comes, how it has its own importance, how we use, how it basically moves up page, because most frequently used pages are saved in cache memory, right? Because like suppose I have searched daily, I search for temperature. Yeah, daily I search for like how many patients are affected. So how I'm going to check it? I'm going to type like my most frequently used pages are this much. So it automatically saves in the cache memory. Then there is no need to transfer it from secondary memory. So I told you each memory has its own importance. You cannot say like we don't have SSDs, SSDs, or we don't have HDDs. So they, the basically the categorization is according to the importance of that particular device. Like if I want to format my computer, right, I need to delete all the things, or I may be saving it in OneDrive, right, or I will be saving my data on cloud. So why to have transfer of such kind of thing? We may be using HDDs, or we may be using pen drives for basically moving our data. So every device has its own importance, right? So after this, like what is cache memory? Let us understand where it is there in the memory, where it resides, how CPU basically connected with the cache memory, how it transfers the pages from cache memory to primary memory, or from primary to secondary. So let us see, it is a very very interesting topic, because I used to have with my BTech students, when we used to have some algorithm how to replace the pages that are, we are shifting from cache memory to some secondary memory. There are number of algorithms that were very very interesting. So I will be sharing one session on different page replacement algorithms that we have in our operating system, or you may say we will be in any architecture when we are studying cache memory, right? So let us understand, this is a very interesting topic. Cache memory is a very high speed semiconductor memory which can be speed up the, it is why it is used for speed up the CPU. It acts as a buffer, so it acts as a buffer, or you may say it is a, like you may say it is my backup, right? And where I am storing, it is just replacing within seconds. It is because it is very high speed. It is providing you very very fast results, right? So it acts as a buffer between the CPU and the main memory. So where it is lying, it is between CPU and the primary memory, right? So it is like most of the people get confused where this lies in memory, or where is virtual memory, what is the concept of secondary memory. Now these are the concept, like when we are studying about this, we are able to understand, like in our practical life also, the most frequently used pages are stored in cache memory. As soon as you type it, just sequence, there is no need to search in the memory, it directly gives you the access and searches from the memory and gives you the output, right? It is used to hold those parts of the data and programs, yes, which are most frequently used by the CPU. So the most frequently used pages which is used by the CPU are stored in the cache memory. No need to transfer it from primary memory, or no need to transfer it from secondary memory. Why we have such kind of thing? Why we have such a long procedure? It is going to delay the speed, it is going to delay the result also. So why don't we have a buffer kind of thing which is storing the most frequently used data, right? The parts of the data and programs are transferred from disk to cache memory. So basically it is going to be transferred from your secondary or primary memory to the cache memory by the OS, from this where the CPU can access them. So basically the CPU can access through them only. It is their communication, right? It is communicating. It is going to have, like you have different pointers, there are basic architecture behind that. You cannot directly access this. There are different addresses part. You have some physical address, you have some virtual address. How it translate, so there are big concepts behind that, how it translates the address. It's a too interesting task. Or how it uses the paging concept or segmentation concept. So there are number of things behind that. It is not as easy as we see, like just to search in a computer and saving your file and then again searching from the computer. So it's not very easy task, but yes, nowadays we know how to use it, so it's very beneficial. Now let us see the level 1 of cache memory or primary cache. L1 is the primary type cache memory. What is that? Cache memory. The size of L1 cache very small comparison to other, that is between 2 KB to 64 KB. It dependent on CPU. So it depends on the CPU which type of memory you are using. It is a embedded register in the micro. Yes, it is the what? It is the register in the microprocessor CPU. The instructions that are required by the CPU are firstly search in the L1 cache. So level 1 cache we have level 2 cache also, right? So first of all, because it is providing advantage the advantage of cache memory is to provide the fast and efficient results, right? So how it is going to provide it? Level 1 cache, most frequently used pages. How to replace the pages? Number of algorithms are used behind that, right? Examples of registers are accumulators, or you may say address registers, program counters we use, instruction register, physical address translation techniques are used for transferring the pages from secondary memory to cache. Level 2 cache or secondary cache. So first we have used the primary cache. So we are using with the primary memory, right? I will be telling you how it works. Basically, I have taken one example also. Level 2 cache or secondary cache is the type of L2 is a secondary type of cache. The size of the L2 cache is more capacious than L1, that is between 256 KB to 512 KB. Now it has already increased. Like our books are showing such figures, but now it has also increased. L2 cache is located on again computer microprocessor. After searching the instructions in L1 cache, if it is not found, then it is searched in the level 2. So how the computer works? How it works? If the pages, like you have the level 1, you have the level 2. If the pages are not within that particular area, it is going to search for the next level. So if it is not present in the L1 cache, it is not if the page is not found, it is going to search into the L2 cache by the computer microprocessor, right? Now there is the third thing is we have L3 cache also, like level 3 cache or main memory. L3 cache is a larger in size but slower, because I told you, when you have small memory, if you are searching something, obviously the memory is less, you can search it fast. If you have a huge memory, the size is huge, if you are searching anything, obviously it would be taking time, right? So here it is also applicable. If you have a large memory, the time would be taken, it is going to slow down your speed, right? For searching the instructions, for searching your data, right? So it is like that only. Like if I'm searching in my home, and if I'm searching in an Almira, it would be different, right? But nowadays we have the different kind of thing. In an Almira we put all the things, right? But it is a computer and it is like we are doing manually, right? So this is just an example, I would say. If you are covering with a large area, obviously the time taken to search anything, it would be taking more time rather than taking less time for. Its size is between 1 MB to, now it has been increased, we have taken from the standard books. In multi-core processor, each core has may have separate L1 and L2, but all cores share a common L3 cache. L3 cache double speed than the RAM. So basically we have that part, but again it is slower. Now this is the basic architecture we have. So I have taken one example so that you can understand where your cache is there and where is your main memory, how we transfer it, how we have the address translation part. We have taken some examples also, some formulas also. So let me start. So this is your cache memory, this part, right? And this is your main memory, right? Now you have a block. Now there are number of things. If it is your memory is divided into paging concept, if it is following the segmentation, then some paging table is to be referred. If it is following segmentation, then some segmentation is to be followed. How it transfer the pages. So basically you have number of blocks, and the same number of blocks is in your cache memory also. Like if the page is not find in this particular thing, right? If the pages, the block or the word is not find in the cache memory, then it is going to be linked to the next part, that is main memory. So now you can easily see the area that is covered by cache memory and the area that is covered by main memory. So searching in a main memory would be taking time, right? Rather than searching in a cache memory, right? So here n is the address lines and 2 to the power n would be the words of memory. So I would be giving some numericals on this, how to calculate a word, like what is the speed of calculating it. So it's like this only. Let's have a formula kind of thing. Cache stores fixed length of blocks, k words. So this length is fixed, right? Cache views memory as an array of m blocks. 2 to the m is equal to 2 to the power n divided by k, right? A block of memory in caches refers to as a line, right? And k is the size of line. Cache size of c blocks, where c is less than m, right? So obviously you may have number of blocks in your this cache memory, you may have more blocks in your main memory. Cache size of C blocks where C is less than M considerably. Each line includes a tag that identifies the block being stored. So where is your block, and it is stored in the main memory. Now you need to transfer it to the cache memory. So it would be taking some time, some replacement algorithms, like which page is going to be transferred and which page is going to be shifted. So it has some criteria. You cannot directly merge both of the things, right? So I will be sharing some concept. I will be sharing like how much time is required to search in a cache memory and how much time is required to search in a main memory, right? So each line includes a tag that identifies the block being stored. Tag is usually upper portion of memory address. So you have, obviously I told you, you have a memory address which is basically in the main memory, and you need to transfer it. Like if you are transferring your pages, you need to search, right? You need to search in the main memory. How it translate? You have some page table, you have some segment table if you are following the segmentation, right? So there are different ways of storing in the memory also. So let us see some of the operations, some of the cache operation, how the cache works, right? So cache cpu request content of memory locations, right? So first of all, because cpu is executing something everything, so cpu requests contents of memory location, checks cache for this data. First of all, it is checked in cache. If it is not present in the cache, if present, get cached and done the task, right? If not present in the cache, read required block from the main memory to cache. Now what it does, it is going to shift, it is going to read the block from main memory to cache memory. So there is something to be transferred, something to be replaced, right? So that's why there is a concept of page replacement algorithms. Then deliver from cache to cpu, then your result can be extracted from the cache memory to cpu. Cache includes tags to identify which block of main memory is in each cache slot, right? So cache includes your tags also, right? You may be translating the different addresses. You may be heard about what are physical address, what are virtual address. We will be discussing on this part also, right? So starting, may we have like how to start. Let us see with the graph part also. We have the start part, and first it receive the receive address from the CPU, and then we have the that part, condition part, is block containing address in cache. So we are checking whether the content is available in the cache. Yes, then directly fetch the word and execute it, and it is basically done the task, right? And suppose it is not there, so you have the no condition also in this. If it is not there, then access from the main memory, get it shifted to the cache, allocate to the cache, right? And then load into the main memory block into the cache line and deliver the word to the CPU. So basically it is giving, it is following all these steps only, right? It is following if and else statement also, and it is following if the condition, like if the page is found in the memory, directly gets fetched and delivered to the CPU. If it is not fetched, then it is going to search in the main memory then convert the text, basically shift it to the cache memory, and then cache memory is going to provide the result. Now let us see what are the addresses, what are the elements of cache design. uh, why we say that cache is more beneficial and cache is so fast, cache is so efficient, why we say such kind of concept, let us see. So addresses part, yes, for calculating the address, I told you, once you are searching for main memory and then you are shifting to cache memory, so it would be translating some addresses part also. You are locating, you are shifting something, you are replacing something. So obviously you are having some address translation part. Second we have is the size that matters, right? How much size you want to maintain, right? Then we have mapping functions, which type of mapping you are going to use, whether it is direct, associative, or you may have set associative methods also. Then we have, I told you, replacement algorithm. You have different, let's say least frequently used pages, or you may say most frequently used pages, or first in first out, or you may say last in last out. So there are different methods, page replacement method, through which you can replace your pages, right? Then we have is write policy. Now write policy, you are writing something into the memory and then just removing it. So write through and write back and write once. So these are the three functions through which we are writing. Line size, what is the size of the line? Number of caches, how many levels, right? Like we have seen, first level may it is going to search, then it is going to search in second level, then it is going to search in third level. So obviously it would be taking, like if you have a larger number of memory, if the size is large, it would be taking the large more time, right? Note that cache design for HPC, high performance computing, is very different from cache design for other computers, right? Some HPC's application perform poorly with typical cache design. So it's very, very important when you are using the cache design, it would be different for different computers, right? So you need to, whenever you use such kind of things, it may be like the performance sometimes becomes poor. Why? Because of this point only, right? Cache size does matter, yes. More cache is expensive, because when you have something that is efficient and that is fast, right, that would be expensive also. I would like cost a bit to approach cost to main memory, cost of main memory, right? Speed, yes. So because you are paying something, so you may be getting the frequent the efficient results, right? So obviously the speed would be more fast, but we want speed to approach cache speed for all memory access. More cache is faster, yes, obviously. Checking cache for data takes time. Yes, larger caches are slower to operate. So basically, like we have discussed this thing in main memory also. If we have more cache, we know that cache is very precious. It is, if we have more cache, we have to pay more for that, right? It would be expensive for us. So if we are having more cache, and if the CPU is going to search in the cache first, so if it is more, obviously, yes, it is fast, but again the speed of that searching speed into the cache, if it is big, it is going to be slow, right? As we have in our main memory, searching from here, then moving from here, then replacing, then, so this is a such a, like you may say, a long procedure, but it takes a few seconds to do that. But again, if you have like larger memories, so your computer may sometimes, like this, you may check out, you need to go to the task manager and end the task, right? Sometimes it gets slow, so you need to do such kind of thing, right? So maybe whenever you are using such type of caches, you need to remember this thing, The advantage, you have some advantages, but you have some disadvantages also. Let us see some advantages. But the advantages of cache memory are as follows. It is faster than main memory. Yes, as we have discussed, it consumes less access time as compared to main memory, because your main memory is much larger than your cache memory. It stores program that can be executed within a short period of time. Yes. So basically, it is storing those pages which are most frequently used, or those within very short period of time. It stores data for temporary use, so it is not storing it now it is permanent, nothing is going to be changed. So it is not like that. It is going to have your such kind of things also, right? So what are the disadvantages with which we have for cache? The first disadvantage is it is very very expensive, right? And cache memory has limited capacity. Like if you are increasing the size of cache, we have already discussed, so obviously it is slower down your speed also. Yes, it is going to slow down your speed. Why? Because if you have large cache, it would be expensive, but it would be like slowing down your speed as well. So these are some advantages, these are some disadvantages. What are the usage, how we use cache. I hope you have understood, and I will be sharing one session on how basically address is translated, because this is very very important topic when you are studying about computer architecture, or you are studying about computer applications also. This topic would be coming under memory management, right? And when we have all types of memory sometimes, so we need to have some page replacement algorithms. And this is very very important in from the point of view like how it actually works, what is the different techniques, what are the different techniques behind that, how we use those techniques. It is not a very like easy task, but there are some formulas, there are some logics. Like most of the people have developed so many good algorithms. They are more efficient also. That's why we have like fast and efficient kind of thing, right? So and this thing also to understand, like when you have a cache memory, or when you have a secondary memory, main memory, how to have like how cpu is going to access, cpu is going to access through cache memory only. First it access the main memory, and if it is not, first it access the cache memory, and if it is not found, then it is going to the next type of memory. So if your page is not found from the first level, then it is going to search in the second level, and then it is going to the, so according to the page found, it is basically matters. Why? Because your speed is also going to hamper while processing all these things, right? So keep in mind while you are learning cache memory, there are two important things. One thing is like how what is the access time. We have the hit ratio, we have the miss part also. Like if I have search in the cache, and it founds the page in the cache, it would be treated as a hit in the cache. And again, if it is not hit, it would be missed. So there are different terminologies also that we have in our cache memory, that I would be taking more sessions on this, like how we have different numericals, how we use different numericals, and how we use different calculations, right? And calculating the access time for taking out or for fetching the instructions or data from the computer, right? So I hope you like the session. So let's move, and we will be meeting in the next session with some more topics on caches and page replacement algorithms, right? Thank you.